In this lecture, we're going to learn about stdoptional. And this is a type that was introduced in C++ 17 to help handle optional output from functions in a much more standardized way. You can think of stdoptional as a wrapper on some type. It is going to contain a value of that type, or it can be empty. So at any given moment in time, it's either going to contain a value or it's going to be empty. Let's look at how we can work with this in C++. Here is a simple example of how we can declare and initialize stdoptional variables. Here we have an stdoptional variable called items, and it is wrapping on int, and it is initialized with a 3 here. This is how you can use it. You say stdoptional, you say angle brackets, you say the type you are wrapping around, and then you initialize that with a value. Because it is wrapping on top of int, we can initialize this little guy with integers. Here we are just putting in an integer literal. We can also set up an stdoptional variable which is going to wrap on top of std string. And the name of the variable is going to be name here. And we can initialize this with a string literal, and it is going to work. Down here you see a simple example using double. It is going to be wrapping on top of double. And we initialize this guy with a double literal here. The name of the variable is weight. And here is another example of how you can wrap around a character type and initialize this guy with a character literal here. So stdoptional can literally wrap any type. And you can use it to encode two kinds of information in your variable. It can either contain a value, like we are doing on top here. All these declarations are going to contain values, but it can also not contain anything. And if you go down here, we have examples where we are declaring our stdoptional variables and not putting in any kind of data. So they are going to be empty. The first one here is going to wrap around std string. The variable name is going to be dog name, and it is not going to contain anything. It is braced initialized to contain a 0 or null version of stdoptional. That is going to be std null opt. Std null opt really means that our stdoptional object is empty or it doesn't have any value inside. This is how we can mean that this guy doesn't contain anything. So we can explicitly say that. You see a simple example here. stdoptional is wrapping around int. The variable name is age, and it doesn't contain anything. It is initialized to std null opt. This is how we mean that here. If we go down, we can see another example where we are doing an assignment. This is going to wrap around the car type. The variable name is letter, and it is initialized with std null opt here. And we can do the same with a double variable. We're going to wrap around a double. The variable name is height, and it is going to be braced initialized. And this is going to implicitly initialize this guy with std null opt here. So this is how you can declare and initialize your stdoptional variables. And again, they can be in either of two states at any given moment. They can either contain a value, like we are showing here, or they can be empty, like we are showing in this series of examples here. Okay, now that we have seen how we can declare and initialize our stdoptional variable, let's see how we can read values inside. And we have two syntaxes we can use. We can either use the value behavior on our stdoptional variable. If we say items and say dot value here, we are calling a function on that type. This is going to give us the value the stdoptional variable contains, and we're going to see it printing on the console here. Another way we can do this is to dereference our variable, and this is just a way to mimic the usage of pointers with stdoptional variables. You can use this and it is going to work, but I personally find this confusing as stdoptional is really not a pointer. So somebody is going to look at this and think you are dereferencing a pointer, but you will be trying to read the value from an stdoptional variable. Note that this is going to work, but it is going to make your code confusing. In my own project, I use the value function here, and it is going to make it very easy to see that I am trying to read the value from my std optional variable. So this is the first and last time I mentioned this way of doing things, because it is just bad. It is going to make your code confusing. I don't even know why they did this in the C++ standard. So if we go down here, we see a few other examples of using the value method or function. So we say name value, weight value, character value. It is going to print the value contained in all these std optional variables. We can also set values to our std optional variables, and the syntax we use is really simple. We just write the type that our std optional object is wrapping around. Dog name here was wrapping around an std string, so we're going to write a string literal inside. This is going to work. Age here may be a size t object or int, but we're going to write that directly in, and we're going to see it when we try to print these two guys here using the value behavior on our std optional variable. Please note that if you try to read from an std optional variable which doesn't contain anything with the value behavior here, you're going to get a crash. So be really careful and know that you have a value inside before you read like this. And we can do this by just doing a check. We can do our check by calling the has value behavior on our std optional variable here. So we are doing an if statement here, and we're going to say if later has value. We're going to note that this std optional object has a value inside, and we're going to read that through this std_cout statement here, or do really anything we want. And if we know that it doesn't contain anything, we're going to say it contains null opt. We're not supposed to read from it using the value behavior. And here are a few other ways you can check for your things. For example, we can check if later is not equal to null opt. This is going to also work. If you go down here, you see that we are doing the same thing. So the main idea here is do your checks before you read from an std optional object. This is how you really work with std optional. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is introducing std optional. We're going to grab our template files like we always do. We're going to put them in place. And we're going to open this little guy in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. This is going to open our folder. We're going to open the main CPP file. We're going to clean it up a little bit. And we're going to close the left pane here. We don't need it anymore. The first thing we want to do here is include the library that is going to give us access to the std optional type. And that happens to be optional. So let's do that. And after we have this included, we're going to show you different ways you can declare and initialize your std optional variables. I am just going to put the code here because it is really easy to look at. The first one is going to set up a wrapper around integer. It is an std optional variable which is going to be wrapping around an int type, and the variable name is going to be items, and we're going to initialize this guy with a 3. Down here we have an std optional variable wrapping around std string, and we are initializing this guy with a string literal. Okay, this is how you can do this. Down here we have one that is going to wrap around double and one that is going to wrap around car, and we are going to initialize these guys with the type that they wrap around. So the last one here, for example, is wrapping around a character type. So we're going to initialize this with a character variable. This is how we do these things. Down here, we see that we can declare and empty initialize, and we denote that our std optional object is empty by putting in std null opt, as you see here. But the first example here is going to use a braced initializer, which is going to put in std null opt implicitly for us. So we can do something like this, and it is going to contain std null opt. We can even put std null opt explicitly like we do here. We can use an assignment like we do here. And we can even do an assignment and put in an empty curly brace pair like we do here. This is also going to initialize with std null opt. If we build this code, you're going to see that it is going to build fine. Okay, the build is good. And if we run this program, we're not going to see anything because we don't know how to read from an std optional object yet. But we're going to fix this in a minute. We're going to look at how to read from an std optional variable. And to read from these types, we have two options. We can either use a value behavior on our std optional variable, or we can even use the dereference syntax like we did for pointers. But again, this is really confusing. I personally don't like to use this. But if you really like this, you can use it. It is going to be supported in your C++ code and it is going to work. So this is a choice you have to make personally. If we go down here, we see that we are keeping using value for name, weight, and character. And we're going to be able to print these guys out. Let's build the program and show you that this is going to work. Okay, the build is good. Let's bring up a terminal here and run this and show you that we're going to see our data. We are going to say rooster and run our program. You see items is 3. If we go on top here, we initialized our items variable here with a 3. The name is Daniel Gakwaya. We are printing this. Weight is 77.2. We are getting that here, and our character is an S. Okay, this is how you may read from an std optional variable. But some of you might be asking, can't we try and print an std optional variable directly? Something like, let's do that. We're going to try things out. We are learning, so don't fear to break things a little bit. So do try your things. We're going to say items here, and we're going to print items directly. Let's put in our second less than sign here, and let's see what we get. You see, we get a squiggly line. This is not a good piece of news, but we see no operator matches the operands. So we can't really print an std optional variable directly on the console like we do here. If you do this, you're going to get an error because it's not meant to be printed out directly. If you want to do that, you need to get the value explicitly yourself and print that out. Now we know how to read from an std optional variable, and we have to use the value behavior or use a dereference operator like this. But we might also want to write stuff in our std optional variable. And the syntax we use is really simple. We're just going to write our values in directly. For example, dog name was containing an std string, or it was wrapping around std string, and age was wrapping around null opt here, and they were initialized to not contain anything initially. But we are putting in values here. Okay, dog name now equals Fluffy. It contains the string Fluffy, and age is 26, and we can print these guys now that they contain some data. Okay, so let's go down and say that we are writing data in and do stdendl to be able to follow this on the console. So let's do that. And if we build this program, the build is going to be good. Build finished successfully. And if we try and run this, we're going to see that we are writing data in. Dog name now contains Fluffy. Age contains 26. Okay, the next thing I want you to see is that if you try to read from an std optional object that doesn't contain anything, you're going to get a crash in your program. So be careful here. We're going to say reading bad data, and we're going to go on top here and find a few variables that don't contain anything. And we have a letter here which contains null opt, and height contains null opt here. Let's go down and try to read from these guys. We're going to put in an stdcout statement which is going to be reading from letter and height here, and we're going to be using the value behavior here. If we do this, we're going to be crashing our program because we know that these guys don't contain anything. So reading from them will be basically reading junk data. We shouldn't do this, but I want you to say this. So we're going to build with GCC. The build is good, so we can clear and run rooster. And we're going to have terminate called after throwing an instance of std bad optional access. This is a way C++ has to tell us that we are doing something wrong here, and we're going to get a crash. We haven't really learned about exceptions by now, but we will later in the course. But for now, know that if you try to read from an std optional variable that doesn't contain anything, you're going to crash your program, and you should really be careful. Okay, so some of you might be asking, How do I then know if my variable contains a value in the first place? Well, I'm glad you asked, and we can use a behavior on stdoptional that is called hasValue. We can use this, and we can check and know if it contains a value. Okay, so for example, we can go down here and say stdcout letter hasValue, and do something like this and print this out. We're going to say letter hasValue. You see that we have this behavior here, and we can print whatever is returned by this function here. Okay, we can go down and say height has value. We're going to say stdcout. We're going to say height has value. And it is a function, so we need to put our parentheses in here. And we're going to put in a new line character using stdendl. This is going to return a Boolean value, so we are going to put in stdcout std alpha, because we want our output to be in the form of true or false. So we're going to build this and see what we get. We're going to build with GCC, and we're going to clear and run rooster. Now see what we have. Letter has value is false, height has value is false, but let's try and use something that has a value inside. For example, dog name has a value, so we can try and do that. We're going to say stdcout dog name has value. Let's put a space in here, and we're going to say dog name has value. Okay, let's do that. If we build this and run the program, we're going to use GCC to build. The build is good. We can clear and run rooster now, and we're going to see that dog name has value. So this is a behavior we can use to check and know if our stdoptional variable contains something before we attempt to read from it. Okay, so now we can go down and do a check before we read. Okay, let's go down and do that. We are going to set up a piece of code to do some conditional reading here. And it is going to say if letter has value, we're going to say letter contains useful value. And if this test fails, we're going to say letter contains std null opt. And we're going to do another version of this check by just checking if it's not equal to null opt. Let's fix this a little bit. And it is going to do the same. So let's go down and put in some information to mean that we are going to run this code here to make it a little easier to see on the console. So we can do stdcout stdendl and say stdcout conditional reading. I think this is going to be descriptive enough. We're going to be able to follow this easier on the console here. So we're going to build the program. Let's do that. We're going to build with GCC. The build is good. We can do these kinds of checks. And if we run rooster now, we're going to see conditional reading. Letter contains std null opt. But if we do the check on dog name, for example, we're going to copy this code here and adapt this to work on dog name. We're going to say dog name. We can adapt this, and we're going to say dog name contains a useful value, and we're going to print that value out. Why not? So we can say dog name value, can call this and do stdendl here. And if we fail, we're going to say dog name contains std null opt, and we have no business reading that, because if we read that, we're going to get a crash. So we're going to say that here. And if we build and run this program, we're going to use GCC. We can clear and run rooster. We're going to see dog name contains a useful value, and the value inside is fluffy, and we are really playing it safe here. We are checking if our stdoptional variable contains something before we attempt to read from it. And this is going to make your code safer from crashes like we have seen before. And again, my general recommendation is to do your checks before you attempt to read from your stdoptional variables. This is really all we set out to do in this lecture, giving you a general introduction on how you can use stdoptional. We are going to stop here in this lecture, and in the next lecture we're going to use stdoptional to handle optional output from functions. Go ahead and finish up here and meet me there.